My name is Anthony, and I'm a product manager at Microsoft. And today we're going to talk about how we can use .NET with Azure Container Apps. Let's get into it. So we're seeing more and more developers use containers to develop and deploy their applications. And we're also seeing more and more teams leverage the microservices architecture to be a little bit more agile in the way that they deliver their software. So Azure Container Apps is a new service in Azure. We became generally available about 6 months ago. That allows you to build serverless containers for microservices. So it's built on top of an open source foundation. So it's built on top of Kubernetes as well as a bunch of other different open source projects. And not only that, you can use open source tooling to build your applications. I already mentioned containers, but you can optionally use things like Dapr, which we'll get into a little bit later, to build your applications as well. And because we're an abstraction on top of Kubernetes, you can focus a lot more on building your apps and not have to worry about managing any infrastructure. And there is scaling built in automatically for basically you can scale your application based on any event that you can think of. So and there's support for scale to zero, so you don't have to pay for anything if your application is not running at all. And Azure Container Apps comes with a free grant, a lot like Azure Functions. So you have, I think, a couple million requests for free, as well as a certain amount of CPU and memory usage every month that are included for free as well. All right, so let's look at what kind of stuff you can build with container apps. So we already talked about microservices, and that's that's just a bunch of services that are running that can communicate with each other either synchronously using things like HTTP or TCP or gRPC, or they could communicate asynchronously through something like a queue. And all of these things can scale based on the events that they're processing. So that's pretty cool. And you can also develop and deploy standard web applications as well as web APIs to Azure Container Apps. And you can, you have access to things like custom domains, TLS certificates, as well as integrated authentication. And all of these apps can scale based on the number of concurrent HTTP requests that you're that you're receiving, and you can configure that per app. So if you have an application that can scale, that needs to scale a lot, you can actually adjust that. And you can also run event-driven processing applications on container apps. And one of those, like a pretty common example, would be an app that reads from a queue. And for that, you can actually have container apps scale based on how many messages are in the queue. So you can actually scale out if the workload increases, and then scale all the way back down, maybe even all the way back down to zero if you have no messages in the queue. And we can also run traditional background processing on Azure Container Apps as well. That's anything that's kind of just processing things in the background, and we can scale those based on CPU and memory. So before we dive into demos, I want to kind of just give you a quick overview of some of the concepts within container apps. As you can see in this diagram, it's a little bit daunting, but we're going to break this down. It's actually not that difficult to understand, hopefully. So all container apps live in a container apps environment. And an environment is basically an isolation boundary. All applications that you deploy to an environment share the same virtual network. And you can also configure them to use the same logging and observability as well. So you can actually see logs and observability metrics for all your apps within an environment in the same place. And as I was saying before, you can deploy one or more container apps to a container app environment. And a container app is basically a microservice, or like an app that you might deploy. So you might have one app that is a web front end for your entire application, and then you could have an order service API as deployed as another app, And you might have an inventory service that might be reading from a queue deployed as a third app. And then within each app, you can actually create one or more revisions. And revisions allow you to, if you want to kind of test out something before you make it live, or you want to do A/B testing, or you want to do blue-green deployments, they're great for that. Typically, you would just have one revision running of your app at the same time, but you can also have more than one app, more than one revision running if that's better for you. And within each revision, you can run one or more replicas, and that depends on the scale rules that you have set for your application. So depending on how much load your application has, the scaler will decide to scale your revision in or out to the number of replicas that it needs. And then finally, within the replicas, you have our containers. So typically, a single container app or a revision has a single container defined, and that's just that the container is running your web app or your background job or something like that. But you can actually run more than one containers together, and that's typically what we call a sidecar pattern. So you can have a main container that's say a web application, and then you can run a sidecar app a container that will, for instance, capture logs and ship them off somewhere else. Those are really useful for that, and those run within a replica. And then, as I was saying earlier, you can do things like A/B testing with revisions within Azure Container Apps. And this is because we have Envoy built in as an ingress. So you can configure that to route all the traffic to a single revision, or you can actually split the traffic amongst multiple revisions. So enough looking at PowerPoint. Let's look at some demos. Right, so let's go to Visual Studio. So here I have a web API project in .NET 7, and I literally just went file new project, and then I chose web API, and then I went ahead and published this to Azure using just the right-click publish mechanism. And then you can see here that it's already been published, and if I click here, it will hit the website. I actually have to go to the right path. And you can see I have some random weather information showing here. So let's take a look at how we can actually build a front-end application that is going to get deployed to the same container app environment that will talk to this API and display the weather graphically. So in this Visual Studio here, I have another application that all it's doing is just kind of making a call to the weather API that I have in container apps, and then it's displaying that information. So maybe the best way to show it is to just run it. So I'm just going to F5. And I've also configured a Docker file for this project as well, so it knows how to build a container. But if you want to try to use the new .NET 7 support for building containers, that should work as well. So yeah, so you can see it's displaying the weather data here, and if I take a look at the logs, I can see down here it's kind of a little small, but you can see there's actually making a call out to that service. All right, let's see what it's going to take for us to deploy this to Azure Container Apps, and we're going to try to do this a little bit more properly. So, whoa, what did I just do? Last time, or for the other app, I just did a right-click publish, which some people frowned upon. I might have already gotten some complaint emails come in because I did that. So this time I'll try to do this a little bit more properly using GitHub Actions. So I'm going to go do the same thing as before and right-click publish, but I'll choose a different option at the end. And sorry, I got to shrink my screen here because I have different scaling happening on this screen. All right. So I'm going to choose Azure, and I will choose Azure Container Apps. In here, I should see a list of all my container apps that exist. I can create a new one. That takes about a minute or two. So I've already created one. And you can see I've done some practicing here. And I'm going to choose Weather Web. So that should be the right one. And then I also have to choose a registry. So the GitHub action is going to build a container image out of my application and push it to a registry. And then Container Apps is going to run the app from that image. So I will go ahead and choose this registry here, click Next. And now, if I chose this option, I'll be able to just click a Publish button and send the app up to Azure Container Apps. But this time, I'll actually set up a CI/CD workflow using GitHub Actions. Go ahead and click Finish. And it's going to do a few things. It's going to set up my GitHub repository. So one thing I didn't mention before is that this application I've pushed to GitHub. So it already has the upstream set up. And it's what it should be doing right now is that it's basically setting a bunch of secrets on my GitHub repository so that when I run my GitHub action, it will have the right credentials to deploy my application. And looks like it's all done. I'm going to click Close. So I have to do one more thing, which is to push the workflow that it generated for me to GitHub. So I can take a look here. This is the workflow that Visual Studio generated for me. And I'm just going to go ahead and commit that workflow. I'm going to commit it and push it to GitHub. That looks like it's happening. Thinking about it. Okay, it's done. If I go back here and I refresh, it's actually going to query my GitHub workflow. So you can see my workflow is ready. And within a little bit longer, yeah, the workflow has started running. So let's take a look at this in GitHub. And you can see the workflow is working. It's running. It's gonna take about 3 minutes to run. It's gonna build the container image, push it, and then deploy a new container app revision using that image. While that's happening, let's take a look at this application in the Azure portal. So like I said, the Azure the application has already been created. I can click here to open it up. It's still kind of showing the welcome page because the workflow is still working, or it's still running right now. And let's take this time to go over some other features in container apps. So you can really easily get access to metrics of your application, so you can see exactly how things are going in your application. In container apps, you can use the authentication feature to add an identity provider. So if you want to protect your web application using things like GitHub or Apple or Facebook, you can really easily just add one or more identity providers here, and it works just like the authentication features in services like App Service and Azure Functions. And if your application needs secrets, this is where you set it. We're going to take a look at Ingress a little bit later. In my application, I used Visual Studio to create my GitHub workflow, but I could have also used this portal here to create a GitHub workflow in my repository as well. And we're also working on support for Azure DevOps. And I can create a custom domain for my application. And I can also enable Dapr in the portal here. So we're going to talk a little bit more about Dapr in a little bit, but you can actually configure the app ID, the port, all sorts of things that you would need to configure for your Dapr application to work properly. And then I can also turn on managed identity in my application. And I can use this managed identity in my code to talk to things like SQL database or Cosmos DB, as well as things like storage, or really kind of any Azure service these days. And you can talk to it without storing any secrets in your application, so you don't have to store the connection string. You can use this identity to call those services instead. And you can also use this identity to do image pulls from Azure Container Registry. And we also have preview integration with Service Connector. And Service Connector allows you to, with a couple of clicks, add and link a like a database or something like that that you might need to that you might want to add to your application. And down here, you can see the different revisions that we have in our app. Looks like the application has already been deployed. Let's take a look at the workflow. The workflow is now green. Things are looking good. Looks like I've stalled enough. Let's take a look back at the welcome page here. So if I go ahead and refresh this, it now shows our weather application that was deployed through GitHub Actions. So as you kind of might have noticed earlier, I kind of went through a little bit fast. You might not have. Currently, my backend API for the weather is actually public, and it doesn't need to be public because the ASP.NET application that's acting as the front end can actually call this within the same virtual network without actually going out to the open internet. So let's configure that right now. So I'm going to go over to my API application, and I'm going to click on its ingress blade. And as you can see right now, it's accepting all traffic from anywhere. I can go ahead and change this to limit traffic to just the container apps environment and click save. It's going to take, maybe 30 seconds for this to happen. So, so now after this is done, I should no longer be able to hit this endpoint from the public internet. So if I go back here and I refresh, you can see that I can't hit it anymore. And let's see what happens to the app. You can see that there's now an error. So we can use this opportunity to show you some capabilities within container apps to help you troubleshoot your application and see how we can fix this. So back in the portal, and this is now for my front end app. So this is the app that's failing currently. I can click here to actually open up a log stream. So this connects to one of my containers that's running in my app. And if I go ahead and clear it, and then I just refresh this error page again, then hop back here, you can see that a bunch of logs appeared. And oh no, keep pressing whatever button I've been pressing to minimize my screen. Let's bring this back. Back. All right, it's back. So you can see that I'm actually calling this URL, and something appears to be wrong here. Let's see what's going on. So another thing that I can do is I can open up a console into one of the containers that are running for my app. So I can go ahead and connect to it here. And then I can just use a curl command and paste in the URL I just copied. And I can see that I'm getting a 404. So it's actually hitting the ingress, and the ingress is like, I don't know, I don't know of this address that you're trying to get to. And the reason for that is that when I changed the API to be internal, I actually got a new host name for it. So I'm actually going to copy the new host name, and then come back here, and then I'll type curl again, and I'll paste in the host name I just copied, /weather forecast. And now I can see that the proper way to connect to the service now is to use this new host name. So let's fix that. So I can go over to my revision management, and I can create a new revision. So, so what I'm currently looking at is what the current revision looks like, and I can go ahead and make a change to it. And the change I want to make is to add an environment variable. So I'll call this weather URL because that's what the app is expecting. Manual entry, paste that in /weather forecast. Click save. And then I can click save here again, and it's going to go ahead and deploy a new revision for me. So that's going to take about maybe 30 seconds or so to do, or maybe sooner. So you can see that the revision is now provisioning. And we recently added support for zero downtime deployments. So it's actually going to keep the old revision up and send 100% traffic to it still until the new revision is up and ready and running. And if you have any health probes that you've defined for that application, it's actually going to wait for all those probes to pass before it redirects traffic to it. So now you can see that the provisioning is happening. Um, and pretty soon, the new application or the new revision is going to have 100% traffic. Let's see if that's happened. I'm going to go ahead and refresh it. You can see it's working again. So that's how easy it is to deploy a new revision to your container app, as well to debug anything that's happening in production. Right. Let's get back into slides here a little bit. So, what we just deployed there was a simplified version of what you're seeing on the screen, which is a pretty typical application that we see customers deploy. You can see there's a UI running as a container app down here, and you can have an order service that is placing messages on the service bus topic, and then a loyalty service is reading it. And Azure Container Apps integrates with a project called Kata for its scaling. And Kata comes with a lot of different scalers. So what Kata can do is it can actually listen to the queue that you are scaling, or that your application itself is listening to. And then based on the number of messages that are in the queue, you can actually decide whether to scale your application out. So how it works is that Kata is running in your container apps environment, in this case, watching the service bus queue. And then if it sees that there's a lot of messages in there and it's backing up, it's going to go ahead and scale out my loyalty service so that it can process the messages quicker. And then when it notices that maybe there's no more messages left in the queue, it'll actually start scaling back in my application. And if I've configured it to scale to 0, it'll actually scale all the way into 0. So that's how Kata works. And I also mentioned that Dapr is built into Azure Container Apps. And you don't have to use this. It's optional. You can see that the application that I deployed did not use Dapr, and it still worked. But Dapr is a nice little toolkit or a runtime that allows you to, that simplifies a lot of the things that you might want to do when you run microservices. So things like service-to-service invocation, state management, and pub sub, those are all kind of provided by Dapr. And how Dapr fits in is that if you enable Dapr in your container apps environments and in your applications, we will run a Dapr sidecar next to your application. So now instead of me talking, like the order UI talking directly to the order service, it's going to call it to the Dapr sidecar and it's going to in turn call your other service. It's also running Dapr as well. And then for the order service, instead of it talking directly to Cosmos DB as its state store, or the loyalty service talking directly to Service Bus, for its pub sub, it's actually going to do this through Dapr. And that creates a nice abstraction. So if I wanted to run this entire application somewhere else, and I decide to swap out, maybe I'll swap in Redis for Cosmos DB, or I want to swap in Kafka instead of Service Bus. I can do this all just by configuring Dapr, and I don't have to change anything in the application itself. That's pretty cool. And I'm going to show you a really quick demo on how Dapr fits into Azure Container Apps. If I go back to my portal here, I have deployed another application. It's a pharmacy application. It's just constantly kind of creating orders and then fulfilling orders. And we can actually look at the architecture. It's a much larger application. It's more representative of what people are deploying today in production. And I want to show you how we can actually observe and monitor this application because Dapr is enabled. So Dapr integrates with Application Insights, and an Application Insights has a really neat feature called an application map. And here you can see the application map for the app that we were just looking at. And I can zoom in and out, and I can do things like click into anything to actually drill into some more information about it. I can look at how this particular receipt generation service is doing. And if I want to, I can go and investigate its performance. And I'm presented with some really rich information about this service itself. Anything from its load to its, basically its response times histogram, as well as things like, how each call is doing. And I can even drill into a specific request if I wanted to. And if I look at a specific request, I can actually see that entire request from when it comes into the order service to when it kind of goes through PubSub and kind of reaches each of these services as they process them. So you actually get this end-to-end view of my application, and it allows me to kind of see how things are going, and then it makes it hopefully a lot easier to troubleshoot because it makes it really easy to kind of see that something is wrong and then drill into it and find the error itself. So hopefully, in the last 20 minutes, you learned a little bit about how Azure Container Apps works and how you might be able to use it with your .NET applications. If you want to learn more about Azure Container Apps, go to this URL here. It's going to land you on our Container Apps documentation, so you can learn more about how you can do more with Azure Container Apps.